Okay, this is our 8th physics lesson. We're in 2D non-projectile motion. We're going to learn combining. We're going to look at combining vectors and determining a resultant, naming that, and doing a few things with that. We're going to start off with the easiest. We're going to have vectors that lie directly on x or y axes. We're going to determine the resultant. Then we're going to take it to the next level. There'll be vectors that don't lie on the x or y axis, and we're going to have to do an extra step. And we'll tear that up even more. And each time we'll have to do an extra step to solve the problems. But you'll notice that we do the same thing as we did in some of the easier problems once we do the first couple steps. And then we're going to describe the resultant. Every resultant should include a magnitude, number and unit, an angle, and then a description. Without the description of the angle from our last section, you can't really know what 40 degrees is unless I tell you something about it. We'll talk about the baseline. Okay, so the resultant and its components. So we went ahead and we broke resultant into components in the past lesson. Well, what you want to do here is we're going to take a resultant and we're going to combine components, put those together, and come up with the resultant. But sometimes we might actually have to break something down too. You'll see as we get through this lesson. But I want you to notice that the resultant has two motions going on, and this resultant that's at an angle is going to have this x component motion. If you take a look, the StickMan stay at that same level. They're still in the same plane the whole time. And also I broke this into the y component. If you take a look at the y component is following that same pattern. So these actually both would occur at the same time. And the thing you need to notice here is that you have the same starting position called an origin from the last section, but they're also going to have the same ending position. And what students sometimes don't like to do is these arrows. If you start over here at the origin, draw origin dot, you have this first arrow, you have the second arrow. Well, it's going to end in the same spot as the resultant. And when you go to draw the resultant, you want to go back and redraw the resultant and have that resultant going from the start to the very end of these components. So this one component is always going to match up, but heads with the resultant's arrow when you draw them in. Okay, so that's talking about going into more difficult problems. We're going to start off with something like this. You got 45 meters north, you go 75 meters west, and you can go just directly there by following this resultant. And so we're going to have to figure out what exactly this is. And this is just an animation going through the different things you have to do to get to it, but we're going to walk through that together. So before we get too much further, just a reminder, the angle determines where your opposite is. So if I change where the angle is, the opposite all of a sudden changes as well. Opposite's always directly across. This is going to be important for some of the math today. The hypotenuse is always the longest side, and adjacent is going to be the other one, or the one on the side that's not the hypotenuse. SOHCAHTOA is going to be used, and there's even more functional versions of this, like opposite equals sine angle times hypotenuse. We'll do a couple different things that will commonly not use this version, but we're going to use versions of these you'll see as we do the math. And then just double check, make sure your calculator, if you go and click on the mode, you should be in degrees. You can't really see it from here, but and once you click mode on your calculator, they're usually radians or degrees. You want to make sure you're in degrees, because we're going to deal with degrees problems here. So the basic problems, we're taking 45 meters north, we're going to put it together with 75 meters west. And it can be phrased like this: what is the resultant of a horse that travels 45 meters north and 75 meters west? Either way, if I just told you to add 45 meters north to 75 meters west, you're going to be doing the same thing. So you're going to start by drawing the origin dot, and so we just draw a dot. The next step, I want you to draw the components in order. So when we're doing this, you're going to draw that first one, that 45 meters north. Draw it in, and we're going to follow that with 75 meters west, and we like to keep it to scale, so we should have the 75 meters a little longer than the 45 meters. And then after that, you're going to go back to the origin, and you're going to draw the resultant. You're going to start it here, and you're going to draw it to the end. So it's going to butt up with the end of the last component you drew earlier. Make sure all your arrows are drawn. I want to see big arrows. This is going to be important because this helps you answer some questions. And then you're going to put the angle closest to the origin dot. So the biggest reason to put this origin dot there in the first place is the angle is always going to be placed right next to that origin, that starting position, because we're going to describe this resultant based on an angle from a baseline later on. We'll see that this would be the baseline. So what's the resultant of a horse traveling 45 meters north and 75 meters west? We're going to use Pythagorean theorem to solve for the largest side. And so what you want to notice the difference between last unit and this unit, at least the basic problems, because they will get a little more detailed. Here you're not talking about an angle and asking you for components. They're telling you something's going directly north and something's going directly west. And so that's why we placed them like this. And now we're going to go ahead and we're going to figure out the hypotenuse. We're going to do the Pythagorean theorem. We're going to have our opposite and our adjacent. It doesn't really matter which one's for the Pythagorean theorem. If you have opposite and adjacent, it doesn't matter which one's first or second, but it's going to be 75 squared here plus the 45 squared, and then the square root of this entire thing. So make sure the entire thing's down there. And we find that this is going to be 87.5 meters. What that just told us was this right here is 87.5 meters. We just solved for C. Now we want to figure out, well, I want to give you a direction. I want to tell you exactly how to get to this spot by following this angle. So let's go ahead and figure out what this angle is. And so that's where the opposite is going to be important, opposite of the angle. And then on the side, the adjacent, which is not the hypotenuse, is going to be important. And that's going to lead you to a tangent. And the tangent of an angle equals opposite of adjacent. I showed you in the last unit how you can rearrange that to solve for the angle. When we're solving for the angle here, we're going to be using inverse tangent. So it's good to have that next to you. Inverse tangent of opposite over adjacent. You need to make sure you know the right opposite, the right adjacent. Opposite's not always going to be the x-axis, not always going to be the y-axis. So you look at where the angle is, and that tells you where it opens up to will always be the opposite. And so you go ahead and do that, plug it in. If your calculator's in the right mode, you're going to get the answer of 59 degrees. If your calculator's not in the right mode, you want to go back, you want to check your mode, make sure it's in degrees, and you should get 59 degrees. If not, you might get an error or something else. So lastly, what we're going to have to do is we have this 87.5, and rounding, you can keep the number around 80. I'd take maybe 88 for this. I don't remember my actual calculations when I typed them in the calculator, but I'm not going really with scientific notation. If I was going with these numbers, this might end up being 88. And then it's at 59 degrees. And the way to do the direction naming, walk it backwards. So you're going north from this origin dot, and then you're going west from that north you're going west by this angle, which happens to be that 59 degrees. So 59 degrees west of north, to the west from the north. Think of that. North first, west. So it's kind of backwards, but once again, I'm going to walk you through that one last time. If you think about where the baseline is, that's going to be the last part here. And you have an arrow going north out of that baseline. From that baseline, you're going west. And so that's one easier way just to determine what this direction is going to be. There is an alternative version of this. Let's see if I did it right here. Oh, this is the magnitude, this is the angle, this is the description. An alternative version. So let's say you went 75 meters west first, and then you followed that up with 75 meters north. Well, if you went west first and then north, when we're doing these, kind of follow the order for this, but when we get to the more difficult ones, I'll try to draw in the x-axis information first and then the y-axis. You'll see as we get there, just so we have consistent answers, but I'll tell you how to judge if you are correct. 59 degrees west of north. If you take 90 degrees and you subtract 59 from it, you're going to get 31. And so if you have the opposite, if you have north of west instead of west of north, you would have to have this number, 31 degrees. That's the only answer you can have here. If you said 31 degrees west of north, so you mix the two up, that just means you had trouble naming your angle. So you did something wrong there. But take whatever, if you want to switch these, if you want to check your answer and you have something other than 59, if you had that 31, but instead of west to north, you had north of west, you would be okay. Those are both correct answers. There's no specific way. It doesn't really matter which vector you start with first. It doesn't matter. To get the correct answer, all that matters is that you start at the same spot right here, and that you end up the same finish line, and that's what happens in both of those. Everything else is just a means to get there. So 2 correct answers here. Okay, what's the resultant of a flying 95 meters per second north with a 10 meters per second breeze blowing east? So we draw this out. We're going to draw the first one first, 95 meters per second north, and we're going to follow that off with a breeze blowing east. So when the plane's flying, it's not going to go straight, it's not going to the right, it's going to go in this direction, this resultant right here, and we throw the angle closest to the origin dot, and then we're ready to solve for the different parts. So we'll start with the determining which ones are opposite, which ones are adjacent. We will also solve for the side right here, and when we do that, 10 squared to 95 squared, we take the square root of all that, we get the 95.5 meters per second, so that's going to be 95.5 meters per second. It's meters per second because I was dealing with meters per second. If it was meters, I would be the unit would have been meters, and if it was meters per second squared, the unit would have been meters per second squared. So whatever units you're using in the problems, the units that you're going to have here. So we have 95.5 meters per second, but we want to determine what this angle is. So that's where the opposite and adjacent is going to be important. Our opposite is going to be the 10 straight across. Our adjacent is going to be on the side that's not the hypotenuse, 95, and we're going to get 6 degrees. So this is going to be a little tiny angle. Once again, I could draw in the angle if I wanted to. So 95.5 meters per second, 6 degrees. Now we have to describe what is this describing, what is this direction, and it's going to be east of north. And just like I said before, origin dot, north is coming out of that origin dot. That's going to be the baseline, and you're going to go to the east by this 6 degrees. So you're going to go east to north by 6 degrees. And your answer should have a magnitude, 95.5 meters. You can round it. If you had 96, that'd be fine. 6 degrees east and north would be your final answer. Okay, so you have, and then you have, once again, like before, if I take that 6 and I subtract it from 90, I'm going to get 84, but I'm also going to have these directions flopped. If you look at your page and you have this bottom triangle drawn instead of this top triangle, you just follow the other direction first, and in the process you're going to get this different direction angle and naming scheme because it's naming it based on this and not on that. Okay, so next level up. It's not much difficult. This requires a little 1D motion before we start a problem. We're going to take this 45 and this 15. They're both on the y-axis. We're going to put them together. So there's only one thing in the x-axis that's 75 meters west. So we only have one x-axis part to it. But we're going to have this 45 meters north, and we have this 15 meters south. We have to call north positive, south negative, and then we do this thing called adding vectors, but we're going to include those directions. Where they're going to have those placeholders. 45 positive plus a negative 15 gives you a positive 30. Don't drop that positive until you turn it back into direction. It ends up being 30 meters north. So now we just took one extra step, and we now have these two vectors, 30 meters north and the 75 meters west, and we're going to take that and we're going to do exactly what we did in the last section. So just one more step further. So we've got that 75 meters west, and I'm going to go with the x-axis first when we have to do extra problems, when there's not just 1, 2, 3, when there's more things we got to do and the more complicated problems. I'm not just going to do the first direction. Once again, you can do whatever you want. You just might have an alternative answer. So I just want you to understand that you got it right if you got it right. So 75 meters west, following the x-axis first. And then I'll go ahead and follow the next step. I'm going to take that, once again, head to tail. I'm going to start off where I last ended. So I'm going to start right here, and I'm going to draw the next vector, and I'm going to go 30 meters north, and then I'm going to go back to the origin. I'm going to draw the resultant out. I'm going to throw the angle closest to the origin dot, and now I'm ready to go ahead and solve for the C, the hypotenuse. So you do the Pythagorean theorem. You got 30 squared, you got 75 squared. You add those together, you take the square root of it, and you're getting 80.1. And so once again, 80.1, I just went ahead and found this side, but now I need to go ahead and find the opposite side right here, straight open, where the angle opens up to. Our adjacent, we're going to go ahead and do that inverse tangent of those numbers, 30 inverse tangent of 30 over 75. We're going to get 21.8. So now we have 21.8, and we're almost done. We just have to determine what are you going to call this from here. So it's going to be 80.1 meters, 21.8 degrees, and it's going to be to the, like I said before, if you follow it backwards, west, then in the north direction from the west. So just a way, if you are not getting, if you understand and just feel like north or west, and you're always getting the right direction scheme and the right direction name down, you can just do it based on what you think. But it's just an easy way to go about it is walk it backwards: west first, north second, and then we got that angle that is placed right in there. Okay, so once again, direction 90 minus 21 is going to give you 68.2. And if you have 68.2, you drew it the different way, it's still correct, but you're going to have west of north next to the 68.2. The magnitude is going to be the same because if you take a look, this 80.1, this distance is the same no matter which way you draw everything else. Okay, so when we get to the next level, there's one more harder level from here. I'll tell you right now, the CP classes that I'm teaching, if you're with me, you might have some extra credit where I might ask you some of these, but we're gonna kind of stop at the previous rigor. But I think you can handle it, and the harder problems you do, the easier it's going to be to do some of the easier problems. But I will, on any sort of study guide for the test, if I'm not going to have these on the test, I won't have them on the study guide. Whereas in honors, we're going to see this level and we're going to get a little harder. But you're all smart, and so I want you to at least try them, because in college this would be any sort of physics-based class. This would probably be one of the minimum things you would do in a class. So it's important to get a head start. And also in math, you do some of this stuff. Okay, so where's Joe located after traveling 45 meters north, followed by 75 meters, 20 degrees north or west? So really, if I was going to draw these together, it's going to be over here. But this doesn't end up being a right triangle, so I can't just do that. I have to do something else. I have to break the 75 meters, 20 degrees to the north of west, and I need to break it into x components and x components here and y components here. So it's important to see which one my opposite side is, which one my adjacent side is, and we're just doing what we did in this last section. So not this lesson, but this lesson 7. And so we're going to go ahead and we're going to figure out the opposite is equal to, so the opposite is equal to sine times the hypotenuse. Once again, this comes from sine of an angle equals opposite over hypotenuse. This is so. But we're going to go ahead and just go directly to it because there's going to be a lot of these steps we're going to be taking. So if you have a little note card and have this next to you, have it. But on the equation sheet, you're going to have sine angle equals opposite over hypotenuse. You have to be able to get to this. So we'll go ahead and plug in our values. 20 over there, 75 is the hypotenuse. And we're going to get up this opposite side. And this opposite side is going to be 25.65 meters. It's not a bad idea to go ahead and write it into your triangle because when you're trying to analyze what to do next, you can see it here. Then we're going to go ahead, take our adjacent side. We want to find this side right here. This is going to be our x-axis component because it lies along the x-axis. 20 cosine 20 times the 75. We're going to get 70.48 meters east. So this is going to be 70.48 meters east. West, not east. West. We're going that way. And so when you look at this, there's going to be one vector that's going to be 70.48 meters to the west, but then you're going to have two vectors that are going to add up because they're in the same direction in the y-axis, and that's the next step we're going to do. So we take the 45 and the 26.5. We're going to call north positive. They're the same way. So you can call them both north positive. Or just realize they're going to keep that north symbol. But plus 45 plus 25.65 gives you plus 70.65. And that plus stood for north. And so now we have 70.65 meters north. And we have that second vector. So we combine these, made one y vector. We have one x vector, and now we're ready to go ahead and take the next steps. So 70.48 meters west, and this once again I'm going with, you don't have to go with the x-axis every time, but I'm going to start with the x-axis just to keep our answers similar so we can check them. Go west first, 70.48, follow it by Röntgen origin dot, so first step, vector, head to tail with the second vector, go back to the origin, draw the resultant, big arrows, every arrow should be on there, because I could ask you more questions about it. Throw the angle right here, and then we're ready to solve for everything. So Pythagorean theorem, you've got the two sides. To solve for the hypotenuse, we're going to take both the square of the first side plus the square of the second side, and we're going to take the square root of it, and we're going to get the largest side hypotenuse. Once again, just get a feel for this, if you ever get a number that's less for the hypotenuse than either of these sides, you did something wrong. This ends up being 99.8 meters. And now we're ready to go ahead and solve for the angle. So it's important that we know this opens up to the opposite. And the adjacent on the side, it's not the hypotenuse. And so now we have our numbers we can throw in. The opposite 70.65, the adjacent 70.48, and you can tell it's going to be close to 45. And when you plug it in, you end up getting something, you might get 45 in a little fraction. But 45 is good. Once again, if you give me a couple decimals, you can. I'm not in my class. I'm not grading to the decimal level, but if you have a free response section with random numbers, you want to make sure you have a close enough answer so that you don't get rounded out of a correct answer. So now we're finally ready. We have our 45 degrees. We have our 99.8. We need to determine what this is. And it's going to be 99.8 meters, which is our magnitude, at a 45 degree angle to the north of west. But once again, when you're thinking about the baseline, what's coming out of the origin dot is the baseline, and we're going to the north of that baseline. So that's our final answer. And the alternative answer would be west of north. Would be just because 90 minus 45 is still going to be 45. So this would be hard to determine if you made a mistake, if you actually named it wrong, because you'd have the same one for this one. Okay, so here's a practice problem. Pause the video, try it out, get a little practice, and then after you're done with that, check your answer. And just one more thing, and then we're going to go to the problem set, which will be another section. I'm going to give you another day to work on that problem set and check your work. Okay, so what's the resultant of this 15 meters per second in a direction 20 degrees to the north of east? Once again, going with the naming scheme, if you're going from origin dot, which I should have drawn, east is coming out of that origin dot. You're going north of east, so you can check that. So we're going to break this into its two components. And then this one, the 5 meters per second current to the west, that's just a x component right there. So we want to find this x component, so we could put it together with that x component. You can see that they're going to be different directions, so there's going to be something that's going to be subtracted from the other, and then we're going to have a single y component when we do this. So we'll solve for the y-axis component, a sine of the angle, opposite over here, times the hypotenuse. So sine of the angle times the hypotenuse is going to give you 5.13 meters per second north. So this is 5.13 meters per second. Once again, draw it into your triangles. I don't do it in the notes every single time here, but it's a good thing to do so you can kind of observe what you're going to have to do next. So you have 5.13 meters per second up, but now we're going to have to find we're going to find this side, the x-axis side, which is cosine because it lies on it's adjacent. So cosine angle is adjacent over hypotenuse becomes this. Cosine of the angle 20 times the hypotenuse 15, and we get 14.1 meters per second east. So we can put that in 14.1 meters per second east. And so the angle shows you east. So we know we're going to have to take this and this, and we're going to have to make one positive, one negative, add them together, and we're going to get an overall x component, and then there's only one y component that we'll add to it. So when you add those, make the 14.1 east positive, we'll go with east being positive, we'll go with the west being negative, and you get positive 9.1, and we take that positive and we turn it back into a direction sign, and we get 9.1 meters east. This should be meters per second east. I'll have to go back later on and fix those notes, and those are going to be that's going to be added to 5.13 meters per second north. And now we go ahead and I'm going to draw the x-axis first and the y-axis second. I'm going to draw an origin dot. I'm going to go east from that origin dot, 9.15 meters. Now I'm right here. I'm going to go north from from where I left off. The head of the last one is where the tail of the next one starts. And I'm going to go ahead and go back to the origin. I'm going to draw the results, and I'm going to throw the angle there. And now I'm ready to go ahead and solve for C for the hypotenuse and also figure out the angle. So to do that, you want to know which one the opposite is. Opposite straight across, adjacent, that's going to be adjacent. It's going to be the side. So the adjacent will be over here on the side, and now we can use that and we can solve for different components. So see, this hypotenuse right here is going to be the opposite, 5.13 squared, plus the adjacent. That's going to be 9.1 squared. And we get 10.4 meters per second. So that's going to be 10.4 meters per second right here. And we're going to solve for this angle, which requires us to know the opposite and the adjacent. So 5.13 over the 9.1, and we're going to get 29. So right here, this now becomes 29.4. That's 29.4 degrees. And now we're ready to describe that. And it's going to be in a northern direction from east. 29 degrees to 0.4 degrees upwards or north from this east. And once again, or you can just think what comes out of the baseline or comes out the origin dot, and that's going to be the last thing you have here. So we're going north of east. And so that's your final answer. And of course, let's take a look at the, I don't like to go back and fix that later on. That should be adjacent. The alternative right answer, since I don't have it on the next slide, is going to be 90 minus the 29.4, so it'd be 60.6, and it would be east of north with the same magnitude. Okay, so lastly, this is the hardest thing you have to do right here. We could add more of these and it would get even more difficult, but in a problem like this, you're going 45 meters, 40 degrees north of east right here. You have to be able to draw both of those out and then determine the components, and then you're going to add the components like we did, add the x components, the y components, the way we do, taking into account signs. So that's what we're going to do here. So here's your 45 meters, 40 degrees to the north of east, and there's your 75 meters, 20 degrees to the north of west. And we're going to go ahead and start by solving for some of these components. So we're starting over here with the y-axis. This opens up to the opposite, so that's going to be sine times the hypotenuse. And when we get that answer, we're going to get 28.93 meters. Once again, a good practice, especially on these more difficult problems, to write it in when you solve for it. And then we're going to go ahead and solve for this side over here. We're going to do the cosine because it's on the side. And so we get the answer 34.47. So now we know we're going right 34.47. We know we're going up 28.93 from this vector alone. So there's your y component, there's your x component. And now we got to figure out this side. So we're going to go ahead and we're going to start with either of these axes. I'm going to try to stick to the y-axis first. And so this opens up to the y-axis. So to solve for the y-axis, it's going to be, to solve for this opposite, it's going to be sine of 20 times the 75. And we're going to get 25.65 meters in north as well. So you can already see you're going to have to add these numbers up together. So that's why drawing this out really would help. Because if they were opposite, you would have to subtract one from the other. So you can kind of visualize what you have to do already. And now we're going to solve for this side. This is the adjacent side, adjacent of 20 times the 75, and we're going to get 70.48. So we're going to get 70.48 meters to the west. So we know we're going to have to subtract that from that, or depending on how we do it, you'll see it in the next one. We're going to call this one positive, we're going to call this one negative. So we'll actually have more of a negative answer, which will go with west. And then we know these two are going to be adding to each other, but that's just to get it in your head what you have to do next. This is what you're doing. You're throwing everything together. And so you have 34.47 meters east. We're going to call east positive. We have 70.48 meters west down here. We're going to call that negative, and we add the two and we get a negative answer because we're more west than we are east, and we get 36.01 meters, and it will be meters west. And then over here, we're going to have the two components that are both going north called north positive. Once again, we are not mixing two separate axes. That's why this is, we kind of deal with this as 1D motion, and then we put together the 2D motion afterwards. So we have here, when we have the positive, we add those together, we get a positive answer. Well, positive stood for north in the first place, so that goes back and becomes north. And we want to have our meters, our unit, of course, because that's part of the magnitude. And now we have our two vectors we're going to put together. So I'm going to go ahead and put the x-axis first because I've been doing that. Once we get to this level, we go ahead 36.01 meters, and we follow that off with the next vector, 54.58 meters. We're going to go ahead and go back to the origin. We're going to draw out the resultant in a direction from start to finish. So once again, these two heads are going to butt against each other, and we're going to solve for our side and our angle. But once we have our angle once again is always closest to the origin dot, and that opens up to the opposite, leaving our adjacent on our side that's not the hypotenuse. So we'll go ahead, and now it's back to the easiest level problem after doing all that work before this. Square the 54.8 squared plus the 36.01 squared. So take each side, take the square root, or so square them each and add those two numbers together, take the square root of that answer, and you're going to get 65.4 meters. So this is 65.4 meters right here. I drew it on there right there. And we want to go ahead and solve for our angle. And so we have 54.58, which is the opposite that the angle opens up into. over the 36.01. You get a feel that this is going to be bigger than 45 degrees because this number that it opens up to is bigger than this number over here. We get 56.6 degrees, and we're ready to go ahead and name everything. Throw everything down in one answer. 65.4 meters, 56.6 degrees, at an angle of north to the north of this west. Once again, if you just want to go ahead and follow backwards to check your answer, the origin dot should have this west coming out of it. And then there's your alternative answer again. Once again, if you have a different answer, if you can take your answer and subtract 90 from it, and then switch the descriptions from north to west to west to north, you're going to see the alternative answer. So always check this. Don't redo the problem. If you have west to north and you have 90 minus this degrees as your answer, this is correct too. This is fine. And then we'll work on the problem set next. Thank you.